Hi, welcome to another edition of Fun with Conceptual Physics, the Momentum and Collisions edition. You're going to have a quiz this week and there'll be calculations on it. So this worksheet you're not going to want to lose, and I'm collecting it for a grade. It's not going to be a 2-point homework assignment, it'll be more than 2. Put your name on this, and this sheet must be completed by the end of the period. So let's get going. I will do a few and then you do a bunch on your own. So the very first question is momentum. The equation for momentum will be on the quiz. However, this is a formula, mass times velocity. For each one of these, you're to calculate the momentum. On the quiz, they're going to ask you which one has the most momentum. I'm wondering if you recognize this one. How much momentum do you think this one has? Yes, you over there in the black hoodie. What did you say? A teeny bit louder. Yes, again? Oh, I see. Since it's at rest, it has no momentum, so you can put a 0 here. For each one of these, you're going to multiply these two numbers. So for this momentum, and momentum has the units of, if you notice, you have kilograms times meters per second. You're to put that on each one of these answers, with the exception 0. 0 doesn't need any units because it has no value. You multiply these two numbers together. So you would take, for example, 16,000 times 40, and you'd hit equals, and you can do that on your own. You don't have time right now during the video, but just know for each one of these, you're going to do mass times velocity will equal momentum. So you can do those on your own. Each one of these we've done before. If velocity is quadrupled, what will happen to momentum? Quadrupled means 4 times as big. Since momentum is mass times velocity, if you quadruple your velocity, so I probably should have written that a little better, so let me rewrite that. P equals space m space v. If you quadruple your velocity, clearly you're going to quadruple your momentum, and this is called a direct relationship. If you use this formula for each one of these questions, you'll understand how to do these. It's very easy. Next, like I said, you don't have time to do this worksheet right now. Just keep up with the notes. Why is it advantageous to extend time during a collision? Your impulse equals your change in momentum. During a collision, you're going to come to a stop. Your impulse is a force times time. To extend is another word for increase. If time goes up, force has to go down. Here's another example, and this will be on the quiz. You have a fullback, and this is his mass. They're going to come to a stop, so this has to be your change in velocity, and this has to be your time. Use this formula, it's the momentum impulse formula, right here, and I'll just highlight that in yellow. Basically, that equation is exactly what I said earlier. Impulse equals change in momentum. This is change in momentum. That's a triangle. Impulse equals change in momentum. So F times time equals m times delta v. You've done these before. Now, when you put this answer down, I want the answer equals space and put the appropriate units on it. I'm going to let you think of the appropriate units. You have to be aware on the quiz, we're going to give you several answers. Some of them may have bogus units. It's up to you to know the units of force. So this answer is not correct unless it has the correct units. I think you can figure out by reading this sheet what the units of force are. Moving on, calculate the impulse for the following situation. Now this, they just want impulse. Impulse, as known up here, is just force times time. That's change in momentum. So you draw those arrows up there and put that statement, or you'll not have a clue what you're doing. So impulse is force times time. Now the units of impulse are Newton seconds. Please be aware of that. Each one of these should have those units on there. Multiply those two numbers together. I don't think I need to do that for you, and you can solve that. Flipping the paper over. We're going to be doing collisions this week, so this is a good introduction. An elastic collision is when objects bounce off each other. Right now, in the front of the class, I'm going to do a small demo during this video. So please look to the front of the class. By now I've taken two cars and had them bounce off each other. That's what's called an elastic collision, two things colliding. An inelastic collision is when two objects collide and stick together. The key term is bounce here. And the other key term, I'm going to give this time to dry, is stick. Right now I'm doing a stick together collision, which is an inelastic. So elastic is bounce, inelastic is stick. You need to know that for the quiz. This is not incredibly difficult when you pay attention. An explosion is when two objects are together and fly apart, away from each other. So I'll let you write that down. So there's three types of collisions. Elastics, they bounce. Inelastic, they stick. And explosions, when two objects fly apart. I'll be doing a demo in about 5 seconds in front of class. So I'll let you write that down. At this point, I've done the explosion collision and you've written that down. So I'll move on. Now remember, the front side you must finish and there's calculations you need to do. Consider a bug flying into a bus. First of all, the mass of the bug is small, the mass of the bus is huge. And you've got to complete a sentence. Well, which experienced the least amount of force? Remember, by Newton's third law, the forces are equal and opposite. So they experience same force. So I'll give you a chance to write that down. When two things collide, they have the same force. So forces are the same. Let me go back up here. And highlight fly apart. They have the same force. Which object experienced the least acceleration? By Newton's second law, A equals F over M, the object with the largest mass will have the smallest acceleration. I expect these statements are written out or you will not get credit. I'm not writing all this and you not write it. So largest mass has smallest acceleration. And that has to, small mass means great acceleration. Big mass means small acceleration. No other way to put that. Now this next statement is impulse. Since impulse equals F times T, and the forces are the same, they'll have the same impulse. So right now, the only thing that's different, they have the same force and same impulse. Let me highlight this. They have different accelerations. And up here, since impulse equals delta P, I'll put it in green, they will have the same change in momentum. So again, they have the same force, same impulse, and same change in momentum. The only thing that's different is the acceleration. That you must understand and make a note card, do whatever you got to do, memorize. Same force, same impulse, same change in momentum, different acceleration. So I'll leave that up there a few more seconds, and like I said, you get no credit for this if this is not written out as I have written it out. Last but not least are these questions down here. I'm assuming you're keeping up. You got a billiard ball moving at 6 meters per second, another that is moving at -6. So let's draw a small picture at the bottom. Billiard ball A is moving this way at 6 meters per second. Billiard ball B has to be moving the opposite way since it has a negative velocity, and they're the same size, so that makes it nice, at -6 meters per second, and they're both 5 kilograms. Interesting. Now, momentum is a vector. Write that down. P vector. Write that down. Right here. It has direction. So, what's the momentum of billiard ball A before the impact? Well, billiard ball A, momentum is this simple formula, P equals M times V. I'm expecting you to do that on your own. And put the appropriate units on it. The units will be kilogram meters per second. And you're going to want to put a plus here, because A is moving to the right. Ball B is moving to the left, so you're going to want to have a negative here. Now, what's the total momentum of both balls before impact? Add the momentum of A plus the momentum of B. Oops, sorry, let me write it down here. The momentum of A plus the momentum of B. That'll be the total momentum. Now, your momentum doesn't have to be a number. It can add to 0. This question here and this question here I'm going to skip. What's the total momentum of both balls after the impact? Well, momentum's conserved. The total momentum before equals the total momentum after. I'll put a T on here. That symbol up here means after. These statements here I'm going to ignore because we're not going to calculate something quite that complicated right now. For now, you finish this, and this is a worksheet, and hopefully you've kept up on the notes.